Hello everyone. Today I will explain the content of Chapter 5, I/O pin peripherals. Starting from this chapter, let's first learn about the peripheral resources of the T5L chip, such as UART serial peripherals, timer peripherals, ADC peripherals, NOR flash memories, etc. Generally speaking, the peripheral resources of the T5L chip are richer than the peripheral resources of the 5.1 MCU on the market. Special attention is the NOR flash memory peripheral, which allows one of our projects to save an external memory, so that we do not need an external memory and can save cost. When learning the peripheral resources of the T5L chip, we mainly refer to the official document, Development Guide of T5L ASC. And then the content of this chapter starts from the simplest I/O pin peripherals. This is the picture of the arrangement of T5L pin. We open the schematic diagram of the development board. From this schematic diagram, we can see that the core is divided into two parts by a solid line. The left side is the OS core, the right side is the GUI core. And the 28 pins on the left are C5L code, which can be directly controlled. The C5L code on the right are inoperable and are used by the DWIN system. And the DWIN system is not directly open to our users. The DWIN system will use these pins to drive some of its necessary peripheral hardware modules, such as LCD screen. The pins on the right are used to drive the LCD screen and also drive the buzzer. Of course, it can also be replaced by a speaker, which is used to play music. T5L also comes with a Wi-Fi module. Of course, the DWIN system will also use these pins to drive some unnecessary peripheral hardware modules, such as buzzer, ADC, etc. And then encapsulate the functions corresponding to these pins. Through the 40 to 03F address of the DWIN memory, indirectly provide our users with an interface to use these functions, which we also call the System Variable Interface. Next, let's introduce the 28 pins of the I/O port. The C5L core of the T5L chip has 3 8-bit parallel ports, P0 to P2, and 1 4-bit parallel port, P3 to P3.3, a total of 28 I/O pins. All I/O pins are powered on by default. The input is floating and there is no internal pull up and pull down. Among them, the P0.2 to P0.7 I/O pins are multiplexed with the UART serial port and the CAIM interface. This can be selected through the register to select the multiplexing function or the I/O pin function. Here, I mainly introduce the P0 content. It is the selection of input and output mode. Here is when 0 is selected, it is input mode, and 1 is selected as output mode. This is the reset function. We open the official document. Find the I/O port introduction, which has a detailed introduction to the I/O port. Next, let's design the routine. We set the P1 pin on the T5L chip to output mode to drive an LED light, and set the driving capacity of the IO pin to 8 mA. In C51 code, we let the LED flash every 500 milliseconds. Because the EK043 development board has an I/O port, but there is no soldering pin header. You need to solder the pin header by yourself, and you need to connect an LED light by yourself. The LED light connection is also very simple. Connect the cathode to GND through a wire, and then connect the anode to P1 through a wire. Then the next step is to design the GUI. First, create a new folder named Code on the desktop, and then create two folders, GUI and C51, under the Code folder. Open the latest software. Click New. Select a resolution and select a file path. Create a new folder named Template under the GUI folder. Then click OK. Here we need to create a background image and icon fill. I have already created the image and you can use it directly. Then add the background image. Here we first generate the ICL from the background image and icon fill. Click DWIN ICL generator. Select background image. Click Generate ICL. Named it 32. And then select Icon Fill. Click Generate ICL. Named it 23. And click Save. After completion, we select Variable Icon Display Control. And set the corresponding properties. The minimum and maximum of the variable are used to determine how many pictures to manage in total. Here, fill in 0 for the minimum of the variable. And 1 for the maximum of the variable. Select Show Background Image. After completion, click Save and Generate. Then download the DWIN set folder to the screen. Copy the DWIN set folder to the SD card. Insert the SD card and power on. When it shows end, power off and unplug the SD card. And you can see that the interface has been displayed. Then we start to write code. We can directly use the project created in the first chapter. Here, I have prepared it for you in advance and can use it directly. Now we click Compile. You can see DWIN shows no errors and no warnings. And then click Save. Then use Download for L051 to download the code. Here is the way to connect LED lights. When the download is complete, the LED light starts to flash. Well, today's explanation is end. Thank you for watching.